So let's start with supervised learning theory, fairly classic settings. I'm given pairs, x, y, that are here. I'll choose them as drawn IID from two spaces, x and y. And my goal is to find a function that goes from x to y such that f of x is close to y for some distance. And typically, I'll consider a loss that captures this notion of closeness that gives me some measure of error on the space y. And then I'll be interested in questions such as, can I get close to what I will call the base predictor, which is the function that gives me the minimal expected loss. So really what I'm interested here is in this expected loss and in finding a function that gives me a small expected loss. And as a small comment, if I use certain losses on certain problems, I will estimate different statistical quantities. And for instance, if I use the quadratic loss, then my base predictor is the conditional expectation of y given x. So there's also, and that last statement to me is quite important because there are many places where people are not interested in prediction in engineering sense, but they're definitely interested in conditional expectancies. So what we have here is a tool set that enables us to estimate conditional expectancies. And so then there's a body of literature on different procedures to estimate a function given training data. So I'll call a learning procedure something that gives me an estimated function from a trained data set. So a trained data set is a finite ensemble of pairs x and y. And I'll say that a procedure is base consistent if asymptotically it converges to the base predictor. So this is the notion of consistency, which is quite common in statistics, but focused on the risk. It's important to say that to keep in mind that this notion tells me nothing about any form of parameters of the function, and I really do not care. That function may not be unique. It's not important to me. My goal is really to minimize the expected loss. And so a very common procedure to tackle these problems is to minimize the empirical risk instead of the expected risk. And I might add some regularization. I might choose a specific function class in which I do my minimization. And the function class, the procedure that I use to minimize this risk, all this is basically the science and the art of supervised learning, which I'm sure you know. So this is our setting for supervised learning. And once again, I'm stressing that I'm really interested in controlling the expected loss and not really anything else.